So now that we've talked about linear inequalities, we're going to talk about quadratic inequalities. So when solving a quadratic inequality, we want to rewrite the inequality so the quadratic is isolated on the left side of the inequality symbol, and so there's a 0 on the right side. We want to factor the quadratic to find the zeros. We plot the zeros on a number line. We pick a test point from each interval and substitute it into the original inequality and determine whether it makes the inequality true or false. And then we shade the regions that test true. Write your solution using interval or set notation. Okay, so let's talk about what that means. So we have this example here, x squared plus 3x minus 4 is greater than 0. Again, we've already got step 1 done. My inequality is on the, or excuse me, my quadratic is on the left side. It's set equal to 0 on the right side. I'm going to start by factoring this, which factors into x plus 4 times x minus 1 is greater than 0. I'm now going to take each of these factors and set them equal to 0. So what this does is it gives me my 2 points that I want to put on my number line. Okay, so I've got -4 here and 1 here. Now, this is greater than 0, which means I'm going to end up using parenthesis brackets once I go and graph this. So I've got 3 regions to test. Okay, so region 1, region 2, and region 3. Okay, so what I mean by testing these regions is I'm going to take a number that is less than -4. So let's say we have -5 and plug that in. So we got -5 squared plus 3 times -5 minus 4 is greater than 0. And again, this is a question I'm asking myself. -5 squared is going to be 25. 3 times -15 is going to be -15 minus 4. 25 minus 15 is 10. 10 minus 4 is 6, and 6 is in fact greater than 0. So then we can say that this region is true, which means I'm going to put a bracket this way and shade down here. Now I want to test region 2. Now I'm looking for a number between -4 and 1. So I've got maybe 0 we could use. It would be a really easy number to plug in. So if I plug 0 in, I've got 0 squared plus 3 times 0 minus 4, which ends up giving me just -4 greater than 0, and that is not true. So this is a false region. I'm not going to shade that region. And the last region I have are the numbers greater than 1. So let's say I plug in the number 2, because that's 2 is greater than 1. So I've got 2 squared plus 3 times 2 minus 4, and again the question is that greater than 0? 2 squared is going to be 4. 4 plus 6 minus 4. Well, 4 and minus 4 are going to cancel out, so I get 6 is greater than 0, which is a true statement. So that means I want to shade the values to the right. So I can see already I've got my solution set right here, and now we want to interpret that in terms of interval or set notation. So set notation, I'm going to say is the values of x such that x is less than -4 or x is greater than 1. And then as interval notation, and I apologize, I'm running out of room here, it's going to be from -infinity to -4, and then we're going to union that with 1 up to +infinity.